Have you ever pondered how light, an entity that seems so simple and yet so complex, behaves? It's a question that has captivated scientists for centuries, and the answer is a fascinating journey into the world of physics. Light, you see, is a bit of a paradox. It behaves as both a particle and a wave, a duality that defies our everyday understanding of the world. Consider the speed of light, a staggering 186,000 miles per second. It's considered the universal speed limit, an unbreakable barrier that everything in the universe must obey. But light isn't just fast. It's also incredibly versatile, capable of illuminating our world, carrying information, and even powering our technologies. Yet for all its speed and power, light is also fundamentally delicate, bending and bouncing off objects, creating the colors and shadows that define our visual reality. It's this delicate nature that has led scientists to ponder a rather daring question. But what if we could somehow slow it down, or even stop it? Enter the concept of freezing light. In a groundbreaking experiment, Italian scientists have managed to freeze light, demonstrating its behavior as a supersolid. Now, you might be wondering, how can light, which is constantly moving at blisteringly fast speeds, be frozen? Well, imagine you're watching a hummingbird fluttering its wings so fast that they're just a blur. Now imagine if you could slow down that motion, not by changing the bird's speed, but by changing your perception of time. That's essentially what these scientists have done with light. They found a way to slow it down, to freeze it, without altering its intrinsic properties. Now let's dive into the concept of a supersolid. It's an intriguing state of matter that combines the structure of a solid with the flow of a liquid. Picture a block of ice that you can pour out of a glass. It retains its structure, like a solid, but it can flow without friction, like a liquid. It's a tantalizing concept, isn't it? But how does this relate to light? Well, when light was frozen, it demonstrated characteristics similar to a supersolid. It showed a kind of structure, like a solid, but it also flowed without friction, like a superfluid. It's as if the light was both a wave and a particle at the same time, a concept known in physics as wave-particle duality. This achievement is more than just a cool trick. It's a step towards understanding the fundamental nature of light and the universe itself. It opens up new possibilities for research and technology, from super-efficient energy transfer to quantum computing. But let's not get ahead of ourselves. After all, this is just the beginning. There's still much to learn and discover about this fascinating phenomenon. This isn't a scene from a science fiction movie, but a real-life scientific breakthrough. Now you might be wondering, what does freezing light mean for us and the future of science? Well, like many scientific discoveries, the implications are vast and far-reaching. This breakthrough could potentially revolutionize fields like quantum computing and telecommunications. Imagine for a moment a computer that operates at the speed of light, processing information in a fraction of a second. That's the kind of advancement we're talking about. In telecommunications, the ability to manipulate light in this way could lead to faster, more efficient data transfer. So let's quickly recap. We've talked about the peculiar nature of light and how Italian scientists have managed to freeze it, demonstrating its behavior as a supersolid. This discovery marks the dawn of understanding supersolidity, a state of matter with solid structure but fluid-like properties. The potential impact of this discovery is immense, and we're just at the beginning of understanding what it truly means. As we continue to probe the mysteries of light, who knows what other surprises are in store for us? Until then, let's marvel at the amazing feat of freezing light.